Alright, so let me tell you one story. I was going to read InceptionNet research paper today, but before that I thought why not try it, and I did with this script, and I'll also show you in under 5 minutes. I'll try to show you this. So I did was I imported Tensorflow library, I created the model, instantiated this. What is this? I searched Keras InceptionNet model. So this came, and I instantiated this into a model and then imported. So let's instantiate this from PIL import image. So this will be this library is important for pre-processing. Then I created this function load preprocess. So let's follow along. So in the parameters we pass the image path, and then we open the image, resize the image to 229 to 229. By the way, Inception it accepts 299. Okay, I must 299. Let me also anyways, it worked with 229 also. Okay, so 229 by 229, and also resize this. Now this is going far beyond 5 minutes. Anyways, okay, so in the first step what I'm creating is, so this is the image, I resize the image and then converting this into array, reshaping it into a suitable format which model expects. Okay, and then creating converting this into a float. And this is the point where I stuck for 2 hours, because I was just passing this pixels values directly to the model without normalizing them, but the model was trained on normalized input, so that's why we have to normalize this, because pixel value ranges from 0 to 225, so we have to divide it by 255 to normalize it. Okay, so this is the pre-processing function, and then open an image. This is my image. Okay, so and this is the one. As when we predict the models, we say model dot predict, it outputs the, because this InceptionNet was trained on ImageNet dataset which outputs 1000 probabilities, 1000 probability probabilities for 1000 classes. So we have to do some pre-processing in that also, on the output also. So I found this repository where every class, so 407 maps to ambulance. So what we want is, we want the, suppose we have, don't suppose, but we will have. So let me first of all import JSON and import this file that I found on the somewhere around in the comments. I found this file. So what we have here is, we have numbers mapped to the classes, indexes mapped to the classes. So when we have 1000 probabilities, our model, when we pass this image, let's say we have 1000 probabilities, so what we want is the maximum probability and the index of it. So what we say is, so here we predicted the predicted and passed the test image, stored it into predictions, and what we want is the argument of the maximum probability that is outputted. Okay, so now we have the index of that, and what we want is, we want to pass it here. Suppose we got 62, and now what 62 maps to is rock python. Rock python. What is rock python? Oh, anyways, what we want is, so this, in this function we can say return the result, that is the index, and then we will also want to we also want to see the class of the image. So this value, we also want to see this value. Okay, so we call this function predicted class name, and then we pass the load pre-process images. So to confirm this model works, we can also say elephant image. Quickly, I have to hurry. Save image as ele. Okay, That's it. Downloads. Cut it from here. Mm-mm-mm. Images. Okay, let's paste it here and see what the results are. What are elephant? Okay, so what our model says, it is predicting African elephant. Okay, so we can see how easy it is. With help of few lines we pre-process the image, and in the one line we instantiated the model, and we just, with these 2 or 3 lines, we predicted the class of the image. So this is pretty classy. Okay, so that's it for today. We will also, obviously this is not much very helpful, it can be, but for a particular uh, problem statement we can fine tune this model according to our needs, which the technique is called transfer learning. We'll also learn that, I'll also learn that and share it with you. Thank you.